Okay, this is LeetCode 2933 high access employees. It says you are given a 2D zero index array of strings access times with size n, and for each index, the index is greater than or equal to 0 but less than n. The particular access time at that index, the first data in it represents the name of an employee, and the second one represents the access time of that employee. All entries and access times are within the same day. Okay. The access time is represented as 4 digits using a 24-hour time format. For example, 0800 meaning 8 o'clock in the morning, or 2250 meaning 10:50 in the evening. An employee is said to be high access if he has accessed the system 3 or more times within a 1-hour period, meaning 10 o'clock to 11 o'clock is a 1-hour period. So anytime within 10 o'clock and 11 o'clock is considered a 1-hour period. Now, times with exactly 1-hour difference are not considered part of the same 1-hour period. For example, 8:15 and 9:15 are example 1-hour difference, so we cannot consider them. Access times at the start and end of the day are not counted within the same 1-hour period. For example, 12 a.m. in the morning and 11:50 p.m. in the evening are not of the same 1-hour period. Okay. So they want us to return a list that contains the names of high access employees in any order we want. So if we look at this example 1, you can see the access times array. It contains some data in it. So, and the output is A. So if we look at it, you can see A appeared at 5:49, 5:32, and 6:21, while B came at 4:57 and 5:40. Now, only A can be considered here because they said if he has accessed the system 3 or more times within a 1-hour period. So since B is less than 3, we don't need to consider B. So now the times A accessed the system are by 5:32 a.m., 5:49, and 6:21, all in the morning. And if we check 5:32, 1 hour from this time is 6:32, and the last time A accessed it is 6:21. So 6:21 is less than 6:32. That is why we considered A valid. Okay, I have this example I'll use to explain what we are going to do. The question wants us to return the users that came 3 or more times within an hour period. And to do that, we should know that we are meant to sort the array so that earlier times can come before later times. So this my example here is already sorted. Now, we also need to keep track of the users and the times they came, and we can use a dictionary for that. So I'll just draw my dictionary. I can call this our key and our value. So let's look through our list. Now, for the first item, we have R. And what should the value be? Since we are trying to keep track of the users that came 3 or more times within an hour, we can use the data structure like a queue. Why a queue now? We use a queue because we want to make sure that all the elements in the queue are within an hour difference. That is, the last element in the queue, the tail of the queue and the head of the queue are within an hour. So let's just try to explain what I mean. So for example, we have this queue. The first time user R came was at 0414. The next time that should be considered valid should be this time plus 100, which is 0515. So now we check. The next time user R came was at 0440. And now this 0440 is still less than this time, so it's a valid time. The next time user R came was at 0515. So we can check. 0515 is exactly the same as this, and they said it must be in the question. They said times with exactly 1 hour difference are not considered. Example 0815 and 0915, which is the same situation we have here. So we can simply pop this item from our queue and add 0515. Now the next valid time that any element is coming should be this one plus 100, which is 0540. Now the next item we have is 0525, which makes, okay, that's the last one. So now we can use the same pattern to do for the remaining items in our array. So our S should have the Q, same thing as T, and at the end we simply want to return elements from our map with their Q length greater than or equal to 3. So now we understand what we want to do. Let's move over to writing the code. So the first thing we want to do is to sort our access times list. Based on the time, and after that we create our dictionary or map. Let's call it access map. We can use default dict so that we can keep a Q as a value. I'm using the Python deck library. And after that, we loop through our access times. Then we get the name and the time the user came. And then we add that time for the user to the map. Now, here we want to check if our access time, our access map is not empty. We get the current user. Now, we want to check if our current user time plus 100 is less than this new time, meaning it's not valid. So to do that, we can do if current user. Let's make sure that the user has some value in the queue first. we'll pop it from the left. Which is removing the first item from the queue. Let's use an int here. Let's convert it to an int here. Here as well. Now at the end, we simply want to return a list of the users if the length of that user's queue is at least is greater than or equal to 3. Now let's test the code to see if it works. So it works. Now let's analyze the time complexity. Our sorting will take big O of n log n. While initializing our map, we will take constant time. The same with every operation done inside this our for loop. They will all take constant time. But iterating through our for loop will take big O of n. And finally, the list we are returning will take big O of u. But however, u must be less than or equal to n. So the final time complexity can be written as big O of n log n plus n, which can be written as big O of n log n, since n log n dominates n. And we come to the end of this video. See you on the next one.